All right, so welcome everyone. Glad to have you here today. We're in November. We're going to be talking about salt today, getting ready for the winter. I'm just going to go through my normal spiel here about just kind of info on the basic stuff of these meetings. So we are recording today. I'll record this component, the Stroud updates, as well as the presentation today. This meeting is every third Thursday of the month from 2:30 to 3:30. The Zoom link is the same every time. And I send out an email. I think I actually forgot to send out the morning email today, so apologies on that. But I send out the reminders. If anyone wants to be on the distribution list or has folks that want to be on the distribution list, please let me know. So attendees of these meetings are folks from the DRWI, folks working in the Delaware River Basin, but not necessarily associated with DRWI, and folks from outside the DRWI. Some have been attending as well. Stroud Center support for doing these meetings is via the Delaware River Watershed Initiative, and we provide some support via CSAW, Consortium for Scientific Assistance to Watersheds. This is the website for the DRWI. Check it out if you like. CSAW as well. So these meetings are just a time for us to all check in, bring up any questions or issues that are going on. We provide updates from the Stroud Center, and we generally do a presentation. So this is me, Dave Bressler, Rachel Johnson, I mentioned her, technician, Krista Reeves, part-time Stroud technician, and Shannon Hicks is the engineer, designer, inventor of the EnviroDIY stations. And then we work pretty closely with Master Watershed Stewards. Two folks who are kind of leads on that are Carol Armstrong and George Seeds. All of these meetings, as I mentioned, are recorded and are posted to this website here, wikiwatershed.org/DRWI. So the primary goal of this EnviroDIY work in the Delaware Basin in association with the Delaware River Watershed Initiative is to support the folks who own these stations, the groups who own these stations, in using them for their own purposes. So we've got all, as you know, we have all kinds of guides and tutorials. And we're also doing, a secondary goal is to analyze the basin-wide data set and develop tools to support groups in doing what they want to do with these stations and outside of that as well. And that's part of what I'll be talking about today is developing conductivity chloride rating curves so that you can get a little better idea about salt in streams. So today's agenda. Oh, I forgot to adjust this. We do have a presentation today, but I'll first go through Stroud updates, then presentation, and then we'll have discussion. So just a reminder on these sensor bundles, just getting into basic updates here. These sensor bundles, we have found over the last several years that sometimes these things can get sealed to these bars. So they can get kind of rusty, and that can start to make this PVC get fixed to this bar. So we're recommending to pull these bundles off. I'll take this pin out and pull these bundles off once a year, or maybe more frequently, even if you kind of feel like you're in a situation where it's getting sticky. And that's just to kind of ensure that you can remove them if you need to. There is this new service request form. It's on this site. You can find it here under service requests. And that form is simply to be used as a, if you're having problems with your station and you obviously need someone from Stroud to come out and troubleshoot, you can fill that out, and it'll ask you to do a few things to kind of give us some feedback on to help us troubleshoot the issue prior to actually getting to the station. So feel free to use that service request form. As a reminder, there's also this support supplies list on the resources page. It was recently updated with some more supplies that can be used for troubleshooting and such. So Feel free to check that out. There's, as you can see, there's links to actually where you can purchase those supplies. And then just as a reminder, there's this recommended roles and responsibilities sheet for managing these stations. So there's basically 4 roles that are laid out: managing the station, doing desktop monitoring of Monitor My Watershed, of the daily data, of the real-time data, doing sensor cleaning and station maintenance, and then doing quality control. And as you see here with these red blocks, getting in touch and reviewing the station on Monitor My Watershed is a key component to all of those situations. So you definitely, if you're working with these stations, you definitely want to get familiar with Monitor My Watershed, which I think most people are at this point. These cell boards, the original 4G ones we put out, as probably most folks know by now, those have had issues. So Shannon designed a new original cell board, which she and Rachel have been replacing, doing a lot of replacements with those. And usually when they do that, they're putting on a new Mayfly version 1.0 on those stations as well. Just a little bit of troubleshooting guidance here. If the station does go offline, but the battery was well above 3.5 volts, it's likely, not definite, but likely that a bad cell board is probably the issue. So keep that in mind if your station goes offline. Just some updates on materials, new materials available on the EnviroDIY shop: the new Mayfly board, new starter kit, that new cell board that I mentioned, this new neat display screen, which Shannon is going to be integrating into kind of some of the new stations and replacement parts when we get, at some point, that will be something that a lot of these stations in the Delaware Basin will presumably be getting. So here's the new Mayfly board. I mentioned version 1.0. She's actually had to go up to a version 1.1. It functions pretty much the same, but it is due to supply chain issues from the pandemic. Oh, one thing there, the 12 volt situation here is one of the main upgrades from the previous Mayfly. This will allow the new Mayfly to communicate with these newer turbidity sensors, with these new model turbidity sensors that are coming out, the Yosemite and the ClaraView. So here's just a close-up of the new cell board, the antenna. Here's this nice display screen. So this will be good because you'll be able to check readings, real-time readings from the station without having to even log into Monitor, if, for instance, the station isn't communicating with Monitor My Watershed. So that'll be super nice for on-site troubleshooting and such. Shannon's still testing the Yosemite turbidity sensor. The Campbell ClaraView is out. And I will leave it at that. Are there any questions at this point before we go on to the presentation? Oh, here's a question from Bert. Forgive my ignorance, is DRWI connected communicating with the Boschkill Association? Bert, do you mean the Deer Park Association?
What I mean is the Boschkill Association is in Sullivan County, town of Mamakating, and then the Deer Park Rural Alliance is in Orange County, town of Deer Park. So it's like 2 separate organizations, but the Boschkill is like really organized as far as monitoring water quality and
okay. Grace, I think, is on the call here today. I'm not sure, but Deer Park Rural Alliance is a part of the official Delaware River Watershed Initiative. They're a part of the the so-called Poconos Kittatinny cluster.
yes.
So if you are working with them, then I guess you are associated with DRWI. Now, I don't know if, if there's official funding or not or anything like that. Yeah. But if you're working with DRA, then I'd say you're working in the context of the Delaware River Watershed Initiative.
That's very positive. So thank you.
Okay, sure. Any questions from anyone else at this point before we go on to the presentation? All good. All right. I'm going to stop share for 1 second and over my presentation here. And I will share again and go into presentation mode. We'll be good to go. Okay, this presentation today is on developing and using conductivity chloride rating curves. So this is the essence of what we're going to talk about today. Often it's using continuous, the purpose of it is being able to convert your continuous data from an EnviroDIY station into chloride data, your continuous conductivity data into chloride data. You do that via a conductivity to chloride rating curve. That curve is developed by collecting, this is supposed to read chloride here. By collecting chloride samples along this trend. So getting chloride samples at base soil, getting chloride samples across this salt spike, getting chloride samples in dilution, and getting chloride samples in base flow. And then lining those up to show this trend. And then you use this equation, apply this equation to the conductivity data, and then you have continuous chloride data. And we'll talk about why that can be useful and important. So our goals for today: document chloride levels, describe how to document chloride levels across the full range of conductivity. We do that. The method here is to do it at base flow, as I just mentioned, do it throughout a road salt flush event associated with winter storms, and also doing it during dilution events. So you can do it in non-winter months as well. You can do it at base flow and you can do it in dilution events in the winter or any time of year, really. And then the goal here also is to describe how to develop a site-specific rating curve, which is essentially that equation that I showed between conductivity and chloride. And the purpose is to, via the rating curve, convert the continuous conductivity data to chloride data. That allows you to compare to chloride toxicity and criteria thresholds, compare to natural levels, compare to biotic thresholds, so on and so forth. And you can also use that if you're getting real into it, you can use that to calculate actual amounts of salt flowing in the stream, otherwise called loads. And then also this can give additional meaning to site-specific conductivity data, mostly just meaning that conductivity is kind of easier to measure than chloride. So once you know what that relationship is at a particular site, then you can easily convert your conductivity measurements from your handheld meter or your continuous sensors or whatever to chloride values, which are a little harder to measure. So conductivity and chloride, a little bit about these two measures. So the higher the conductivity, generally, the higher the salt in the stream. Confirm this at a site via direct measurement of chloride. So to that point, we generally, you can see general trends in relationships between chloride and conductivity, but it is site specific. So you want to measure chloride on an individual site basis to confirm what that actual relationship is between conductivity and chloride. So conductivity is an indirect way to measure salt, but there is also natural conductivity, which needs to be accounted for. And that's part of the reason for doing site-specific conductivity to chloride rating curves. So you develop that conductivity to chloride rating curve to explicitly see that relationship for a site. And then that obviously, because a lot of this conductivity and chloride problems in places like the northeastern US are due to road salts, that gives you additional insight into road salt and de-icers that are flushing into streams in the winter and also contaminating groundwater throughout the year, which is a pretty big problem. So the process that we're going to talk about today is to measure and record chloride and conductivity at different times that being at base flow, during salt spikes, and during dilution events. We then plot that range of conductivity and chloride values in a scatter plot in Excel or another graphing program. And then you fit a curve to that scatter plot and display an equation from that curve. And then you use that equation to convert your continuous conductivity data, or you can just use it to convert individual conductivity measurements from a handheld meter or something. So going to this graph again, we have steps 1 through 3 here. So we've got conductivity here, we've got time here, and I think I mentioned the title slide, I said that should be chloride. Sorry, this is time. This is conductivity and chloride here plotted against each other. This is time. We've got base flow here. This is base flow for anyone that is not familiar with that term. Base flow is sort of the standard kind of level, stream level, when there isn't any sort of precipitation event happening. So what we have is the idea of collecting a chloride sample during base flow, and this is conductivity here. So we have a salt spike in which conductivity goes up, and the idea is to collect chloride samples along this curve, doing that using these, you can do it a number of ways, but what we're recommending here is using these hot chloride strips and doing chloride measurements down here in this dilution part, and then you can do base flow measurements again later. One thing to mention, this is one kind of hypothetical type storm where you get a salt flush and then additional water coming in that dilutes it, and then you're back to base flow. But you can do this over multiple storms, and I'll talk more about that a little later. And then you enter the data into a spreadsheet. This is just example data, but you've got conductivity data going up, up, up during a spike. And then you've got your associated chloride data for those conductivity measurements at those same points in time. And then you're going to plot conductivity and chloride. Generally, it seems best to have the conductivity on the X and chloride on the Y, but that's, it's just, you can fiddle with that. And then you plot this equation, and that equation is what you use to convert conductivity data. So here, this is just an example, but we have that same equation put in here into Excel, and it's referencing this cell here, and then it gives you a chloride measurement. And then what you can do is plot that chloride data. And as you can imagine, this then allows you to compare that chloride level to existing criteria and thresholds. Probably should have had this slide before, but this is your equipment list. So specific to the work here, which is the main component, are these chloride Quantab test strips. There's a low range from 30 to 600, and then there's a high range from 300 to 6,000. If you're in any sort of urban area, it's very likely that you're going to need both the low range and the high range. So that tells you about what you're sort of working with in terms of chloride ranges during salt flush events in the winter in northeastern PA, northeastern US urban areas. There's also a conductivity chloride rating curve sampling sheet, which is going to be accessible on that Wiki Watershed DRWI page. You can enter your field data into that, and there will also be an electronic version of that you can use for developing those curves. You want to take your smartphone if you're using Monitor My Watershed so that you can access the real-time data, or you want to take a calibrated conductivity meter. Take your sensor brush if you're working with a station so you make sure the sensor is clean before you record any data. And certainly this is pretty close to what the Isaac Walton League is doing. A lot of folks are already doing that, so you could integrate your work there and just bump it up with doing it at monitoring stations or with adding a conductivity meter to your work. And then obviously there's sort of the general equipment too to take with you. So here are those strips. Basically you take one of these strips out, you put it in about 1 inch of water, let that take for a couple minutes, and it'll form a black line here, tells you it's ready, and then it'll form kind of a white line coming up here to a number here, and then you just use this this key to tell you what the concentration of chloride is in that sample. So it's super easy. It takes a couple minutes, very straightforward to do, and the results are pretty accurate, really. So where will you do the sampling? I've already alluded to this, but certainly a lot of folks have EnviroDIY monitoring stations. Obviously, this is an EnviroDIY focused meeting, so a lot of folks have those stations, so you can do it at those. Certainly, you can do it at USGS stations. A lot of those stations have discharge calculations there too. So if you do it at those, you can also get salt loads at those stations pretty easily because you already have discharge. And you can certainly do it anywhere you want. You don't have to have continuous data to do this. So just getting into a little more detail, this is real data from somewhere in the upstream Philly cluster. Well, anyway, this is in Philly area. So we've got conductivity in blue, we've got water depth in orange. You can see here, base flow, you can certainly collect samples during base flow. You could collect multiple samples or do multiple measurements along here. And then trying to get measurements, chloride measurements along this conductivity hump. If this is an older station, it's been out a couple of years, you will have an idea of how high the conductivity has gone in past years. So you want to use that as frame of reference for when you want to start sampling at present. So, you know, and sort of letting that guide your efforts. As I mentioned, you can also do it during dilution events. So you can see here conductivity in blue again, water depth in orange. You can see water depth goes up, and this is, you can see in October, so this is probably not a snow or ice event, but conductivity is getting diluted, and you can collect samples all along here to get the full range of chloride values throughout the entire conductivity range that you're seeing at a site. And as I point out here, you do not need to do this during a snowstorm or even in the winter. You can do it, you could be doing this right now during base flow and during these dilution events. And obviously dilution events vary, as do salt spikes. So you could, you know, if you get a big storm that comes through, you could get, you know, a pretty heavy dilution event here. You can see here, this one is diluting from 600 all the way down to almost 50, it looks like. So that's a pretty good one where you're getting the full range of conductivity there. Well, at least from base flow to dilution. And then important point here is that you don't have to do it. I was showing individual storms there, but you don't have to do it all in one storm. You can do it over time. So you can see here, I have just example times when you could collect base flow somewhere during a dilution event. Here, maybe you get it right at the bottom of the dilution event. And then a salt spike comes in, going up. Maybe you can't time it to get everywhere along here, but you get it here and here. And then you wait, maybe you get another base flow sample. Or maybe you come here and get it at the dilution. Then another storm comes along. You've got lots of spikes here. So you get a couple, you try to improve from the last one. So you got down in here on the last one. Now you try to improve on the next one, moving it up a little bit, getting here. And another one come, maybe you don't get out for these, but you get out for some more here, and you even get a higher one up in here. And then maybe you decide to get another dilution event. So you can have fun with it, and you don't have to feel pressure to do it all at once. Now, obviously, if you're trying to get a winter storm, a solid winter storm, we never know how many storms we're going to get. In 2019, I think a lot of sites in southeastern PA got one real event in which salt spikes happened. And then last year came around, and there was just week after week after week with salt flushes coming. So it's probably good to do what you can on the first storm and then build on that. So here's the data sheet that is going to be available. So you can print this out and record your data. What it has here is site ID, stream, general narrative location, and then you've got date and time for conductivity. So you've got the first 3 columns for conductivity. So you record your conductivity there, and then you've got chloride, and then you just mention in these 2 spots just your method of how you did it. That's just for your records. So pretty simple sheet. Once you've got those data entered, then all you're going to do is plot them, plot conductivity. If you're working in Excel, your first column is going to be plotted on the X, your second column is going to be plotted on the Y. So you can just enter your data as they are in your hard copy into that sheet and do the plot in Excel, and you come up with this equation. This equation here, and then what you do is take that equation, as I pointed out earlier, plug it into alongside your continuous data, and then that converts your data, and then you can plot it in a time series plot in Excel or whatever other program you might be using. And then it gives you, then you can, as I show here, you can reference certain criteria, whatever criteria you might be interested in. What I have here is a natural chloride level, which is about 5 to 15, less than 20. You can see this site, which is a real site in southeastern PA, pretty much is all the time far exceeding natural levels, and it's pretty much all the time, other than when it's being diluted from lots of rainwater, is far exceeding the EPA long-term chronic exposure toxicity threshold as well. I'm going to show a few example rating curves here. This one, you can see we have a linear plot, and the maximum conductivity at this site is about 7,000. That was one event, so that's the very max. Other spikes were much less than that, in the 2,000 to 4,000 range. And then the minimum goes down to 10. So you can see that this rating curve, which has about 6 points, I guess, is kind of missing that dilution time. And it's also missing the far high end of the conductivity spikes. Now that can be hard to get. So there's no issue if you don't get the full range. You're no matter how you look at it, you're kind of it's kind of coarse work that this is. Conductivity is a relatively coarse measure, and these chloride strips are a relatively coarse measure. And so, you're trying to get a relatively good association here, and the best thing to shoot for is to work with that full range. So here, this is a pretty comprehensive curve. This is one that Carol Armstrong developed for the Pickering Creek near its confluence, and around Phoenixville. And she's done a pretty darn good job of getting across the range. But there's a few peaks that have gotten up into a range higher than, the 900 or so that she got. And there's a small bit of area down here in dilution that still hasn't been covered. But you can see this is a pretty good association here, and there's quite a few points in here. So you can feel pretty confident that this is showing a pretty reliable relationship between conductivity and chloride here. You can also start, as you develop this, you can also start to pay attention to these general kind of ratios that you see between the conductivity and chloride values. And it's often between like 6 to 1 or 1 to 6 and 1 to 3 as you go up here. Here's another one. This was a nice curve that Patty Haug developed on a super urbanized stream in Westchester, PA. And even though she got up to 15,000 in her sampling, there's been a few times where that stream has gotten up to 40,000 or more conductivity. And it also is an urban stream and gets pretty flashy flows that dilute the conductivity a lot. So it does get down pretty low in dilution. So there's still opportunity there to flesh that out. And this area is important because you can see that this line, as you go down into the very low conductivities, this line is going to cross here. So when you apply this equation to your continuous data, those super low dilution events, this equation is going to convert the conductivity values to negative numbers. So that's something to consider if you really get into this, and you can start using curves other than linear, and you could also use a broken stick type thing where you fit a linear curve for this small section here, and then you use this one for this main component of the curve. So how are we doing on time? It looks like we're pretty good. I'm going to keep going, and then we'll take a pause and I'll review the chat. Here are some thresholds from various agencies, federal, state, etc. So here's the one I mentioned earlier, EPA aquatic life criterion for chronic or long-term is 230 milligrams per liter chloride. You can see here I have the natural chloride displayed as well as 5 to 15. That's generally, as far as I understand it, across most sites, that's about the general natural level. And then there's a acute threshold of 860, which a lot of these urban sites are exceeding during these events. There's a drinking water standard, secondary drinking water standard of 250. Michigan, I'm not sure if we have any Michigan Trout Unlimited people here today, but we may. There are two criteria there, 150 as their chronic one, so quite a bit lower than the EPA's 230. So that should be suggesting to you some, idea about like sort of some gray area as far as like, well, what levels are really affecting biota and how do you measure effects on biota? 640 is their acute. Canada, you can see the Canada government, Canadian federal government, all the way down to 120 as their chronic threshold. And then they've got their acute as 640 as well. New York ambient water quality, chronic is at 250. The Delaware River Basin Commission for the Delaware River in zones 2 and 3 down in the Philly area, 180 for zone 3 and all the way down at 50 for zone 2. And then the Maryland Department of Environment and their Maryland Biological Stressor Identification process recommend a threshold of 50 milligrams per liter chloride. So that's about as low as, well, there's a few, I'm going to show some evidence from some papers that point to even a little bit lower than this as affecting biota. But you can see it's a gradient, and so more sensitive species are going to be affected more dramatically by low levels of chloride. But one thing to point out here, when chloride exceeds any of these thresholds, it is evident that salt is creating conditions that are stressful or lethal. So that's the idea here of showing this range that, most likely throughout this range, there are going to be different organisms that are affected differently. Okay, so why don't I stop here for a second, and I'm going to stop share. We're okay, and let me just look at the chat here and see about some questions. Okay, let's see, Bert. Krista, chime in if there's anything you want to tune me into rather than me reading these chats. Let's see, Kevin, don't the strips measurement may have the ppm and milligrams per liter are the same thing. So we're good to go on that. I think that key may be in ppm, but it's milligrams per liter is the same. So it's all good there. Let's see, Jake Lemon, I'm curious where you found the natural chloride level. Just wondering if it only applies to SPA or if it is more broadly applicable. That's a good question. As I understand it, that is, I mean, unless you're in a, you may want to check into that in your area, Jake. There may be kind of some natural limestone situations that bump that up a bit. I don't think it's going to be a whole lot higher, but we should probably, to move, you know, I've been really grinding on this the last week or so, but we should, to build this out more, it would be good to have have some actual sort of real documented levels there. That's just my understanding about really in kind of southeastern PA and the Delaware Basin. So I can't really speak too much to more broadly, but the chloride levels in general are going to be, natural levels are going to be, as I understand it, I'm not an expert, but I think they're generally going to be quite a bit lower than a lot of these thresholds. Any other questions at this point? Good. Okay, we are at 3:10, so I will move on because I'm going to get into some biology stuff here and implications. So, all right, so are thresholds the whole answer? Does crossing a threshold mean dramatic things will happen? Well, so I pretty much just already described that, where it's obviously going to be a gradient, where presumably even at 50 milligrams per liter, certain organisms are going to start being affected. So even if you're crossing 230, you know, it's not like you're going to have massive die-offs of things as soon as you cross 230 or even 860, because if you're hitting 860, it's likely that that's already a stream that's being hammered. And I'll mention this in a little bit, but if you are getting salt spikes, then it's very likely that your groundwater is contaminated also, because spikes have been shown to pretty much be an indicator of salt loading in the watershed as a whole. Loading meaning, I'm using it kind of unconventionally there, but meaning seeping into the ground and into the groundwater. So those salt spikes, which are an indication of salt application, are kind of an indication that groundwater is probably contaminated as well. So extirpation, gradual decline, a gradient of stressfulness. Extirpation is kind of a term that gets thrown around with these varying levels of chloride. And this is just a quote from this Moore et al. Paper. Substantial changes in macroinvertebrate and fish communities have been observed at chloride concentrations of approximately 50 to 90 and 33 to 108 respectively. So that's suggesting that these higher levels that are, you know, at the national level are not entirely protective of biota. And they even go on to say that in this more article. Additionally, recent studies suggest that the current EPA chloride criteria may be insufficient for the protection of sensitive freshwater organisms. Certainly sensitive is a key word there. There's plenty of organisms that are much more tolerant of salt, including trout. Trout are generally going to be more tolerant because of their life history of being fish that do go to the ocean. This may be a little bit much, but this is a graph from this Cormier paper from 2018. These categories are level 3 ecoregions. You can see 64 here, which is right in here, is our general region in southeastern PA. You can see the Delaware Basin covers a number of different ecoregions. But you can see proportion of genera extirpated as conductivity goes up. That's conductivity. So scale that back to chloride. And I could have, if I had thought about it, I would have given you some chloride numbers here, but that's going to vary site to site anyways. But if you scale this back to maybe a quarter of these numbers as chloride numbers, you can see that they're really predicting quite a bit of change to happen, as those conductivity numbers go up. As I mentioned earlier, summer base flow seems to be very important because these urban streams are running at base flow levels that exceed, as you saw in that earlier graph, that exceed levels, chronic levels. And I'm changing that because I got that wrong. Let me go back to my presentation mode. So mentioning here this paper that John Jackson and Dave Funk wrote here at Stroud, these mayflies that they tested 4 mayflies, and there was dramatic change in toxicity between 20 degrees and 10 degrees Celsius. So that's about 68 degrees, kind of normal levels for a trout stream in the summer. And what you see, what we're talking about here is 456 milligrams per liter chloride over this 96 hours killed half of these mayflies. So that's a pretty severe toxicity issue, and that's at 456, right? So that's approaching the level that these streams are running at base flow in some of these urban areas. So there's no chance that a lot of these streams are going to be able to support mayflies. And this is like a really toxic effect. This isn't even considering sort of like the sort of gradual extirpation that Cormier was talking about in that last graph. Just for frame of reference, in terms of what this actually means in terms of just real salt, as in like salt from a shaker, that 767 milligrams of sodium chloride that is associated with this 456 milligrams of chloride is about a half a teaspoon of salt per gallon of water. That gives you an idea of what that concentration is. Certainly you can't taste it at that point. At least I don't think I could. This is pretty busy, kind of complex, but these are the 4 species that John and Dave looked at, and I probably am not going to have time to dwell on this too much, but you can see we have temperature on the bottom here. We have the LC50, the toxicity, the point at which half the organisms are killed. And you can see that levels are pretty high here at low temperatures. At 5 degrees, it took 5,857 milligrams of chloride to kill half of the Neocloeon triangularifer species of mayfly. This one here, it's abated. But you go down to 20 degrees, they stopped it at 20 degrees here, or sorry, at 25 here, and it only took 221 milligrams of chloride. So that's where it's like, well, these base flow levels with this contaminated groundwater are practically more impactful or maybe more impactful than the salt spikes happening in the winter. Now, the salt spikes are obviously the reason, the way that the groundwater is getting contaminated. So that's obviously important to consider. And here, over here in this other, this is the Procloeon fragile, 465 milligrams per liter. So, and just pointing out here again, this is a short-term 4-day average of toxicity. So, it's important to consider what that might mean for, at these types of temperatures that a lot of streams are going to be throughout a lot of the year, what that would mean for the bugs in those streams in non-winter events, just because of contaminated groundwater. Here's another plot from that Jackson and Funk article. This is during these are 96-hour averages here. And just again, pointing out this one species that this is a chloride level that is pretty consistent throughout this salt event. And that if there happened to be this species in there, they would be not faring very well due to that single event. Okay. Actually, I'm sorry, I think I misstated that a bit. It would actually be up here because this is at what it would be like at 20 degrees. But anyway, this is giving you some idea of, you know, these spikes and where these spikes are going to be influencing these creatures. So 318. All right, so we have instructions for doing these rating curves. They haven't been posted yet. They'll be posted here. And I think maybe I will go through a few more slides here and then we can review that sheet. Before I do that, I wanted to point out that if you want to do this work, if you have a monitoring station, or if you even have other sites where you don't have stations that you'd like to do this work, I've been given the go-ahead from John to provide folks with chloride strips if you'd like to participate, for free, that is. So if you do that, if you do this, whether through our Stroud support or not, it would be great if you kept us in the loop on your work, on your data, and what you're finding with these curves, because it seems like we're having some time and goals to move forward with developing these on a more comprehensive basis to get really a better idea of how things look site to site and across the Delaware Basin. Okay, so here are the citations that I mentioned. Feel free to access this presentation. The video and the actual presentation will be on that Wiki Watershed /DRWI page. Contact me primarily. You can certainly reach out to John if you have any like super fine-tuned technical questions. He's the expert on this, at least more of an expert than I am. So I am going to, feel free to ask any questions, but I'm going to bring up the guide sheet now to just kind of quickly review that. So this is just the sort of guide that you can take out in the field with you. And it pretty much is just a boiled down version of what I just went through there. So you've got the methods overview, you've got the all the stuff that you'll need to take out, some guidance on where to sample, when to sample, you know, again, just pointing out the sampling during base flow, across the salt spikes, and during dilution events. You can certainly get multiple base flow samples to see about that variability. You can get multiple dilution events, you can get multiple spikes, and put all of that into a single rating curve. And you could even potentially, I mean, depending on what things look like in dilution events, maybe you do see a difference between winter and summer, but I think that's a level that we're not quite sure about yet. And then it goes through the detailed steps. So just 1 through 4, where if you're measuring doing your measurements, and then you're going to plot the data in Excel. The example here is through Excel. You can obviously use whatever program you want. And then you're going to put in that equation, and then you're going to apply the equation to the continuous conductivity data, or just apply it to a single conductivity point, or multiple points that are just from a handheld meter or something like that. Okay, so I hope I wasn't rushing too much with that. We have, it looks like about 8 minutes, and I think we do have some questions in the chat. Let's see, so Carol, might be interesting to point out that water main pipes that break cause more fish death than stormwater pipes breaking. Drinking water main pipes, huh? Do you want to expand on that, Carol?
Well, you know, we think about, you're talking today about the risks to the macroinvertebrates and fish from the chlorides in the water, but this is a source of chlorides that we don't often think about. So this is our own drinking water that the mains carry more chlorine than the pipe that goes to your house. So when a water main breaks, it really puts a lot of chlorine in the water. And it's just, I know here in Chester County, has been, it's caused the most fish death than any other accidents that we've had.
Okay.
It occurred 2 or 3 times. I don't know how much I don't know that it's entering DEP's long list of concerns. I don't know if it's very high, but it's just good to think about because all of our pipes are aging.
Okay, good, thank you. All right, other questions about the presentation, or we can certainly go to broader things if no one has any questions about the presentation.
I just wanted to put one more reference out there for people. There's a really great paper from a couple of years ago. It's called Freshwater Salinization Syndrome on a Continental Scale, and I'll go ahead and drop that in the chat. It's not only talking about salinization, but the link to pH trends going towards the more alkaline. So if you're seeing that trend in your waterway as well, it could be tied together because those two are in lockstep. So if you wanted to check that out, I put that in the chat.
Good, Krista. Yeah, Kaushal, Kaushal, is the guy who's doing a lot of publishing on the freshwater salinization stuff, and that's a article of his. If folks don't know, this salt is not only affects biota, but it affects infrastructure. It causes, I mean, a lot of that, as I understand it, at least to some extent, that salt in urban areas causes the concrete to corrode, which brings in a lot more calcium, and that's the pH effect that Krista's talking about. And the salt also causes increased rusting and stuff like that of things like cars and bridges and whatever's metal in urban areas. Let's see. Mark, have you seen salt levels in roadside ponds turn the ponds into meromictic ponds? Meromictic. Mark, refresh me what meromictic is.
Yeah, hi, this is my first visit, but meromictic means
Don't mix, okay.
Won't mix.
Gotcha.
We've had this in research I did in University of Michigan where that was occurring in small ponds. And then when you had big storms, sometimes it would actually cause the mix and have fish kills within the ponds.
Yeah, that certainly wouldn't surprise me. I mean, certainly ponds, especially if they're ponds that are directly draining, you know, if they happen to be like actual stormwater ponds or something that have fish in them, but even ponds that are like getting runoff from roads or just getting groundwater from urban areas, I would certainly expect that to be the case. And I know in certain areas, I remember looking at some paper recently where they were talking about salinization in ponds. So that certainly is an issue.
Mark, could you just explain that a little bit more? Are you saying that the salt interacts with temperature to cause the meromictic conditions, or what's the mechanism?
Yeah, thank you. And this is, if you can see my hair color, my graduate work was a long time ago, but what we were seeing is that over extended periods of time of salting in the state of Michigan, the water density, because of all the salt, was just much higher in the bottom. So you essentially had a anoxic dead bottom portion or sub portions of these bodies of water. And so when you got your normal isotherm once or twice a year, those really dense areas from the salt concentration were not typically mixed. But in big storms, it could force the whole thing to mix and then have significant kill if there was fish or invertebrates in different higher levels.
So meaning the fish were living in the, where were the fish? The fish were in the salty area?
No, they were staying up above that. There was no oxygen for them. And your invertebrates were obviously on the shallower sides of the ponds, but it really turned the bodies of water into almost two parts. You would have a completely anoxic dead portion at the bottom, and then you could have life at the top that could sustain for a while until these big storms would come, and then again cause mixing of the whole body of water.
Mark, you don't have a paper documenting that, do you?
I will,
Or
this
send?
goes back some time, but I will dig into that and send that to you if I can find one.
Cool, yeah, I'd be curious to read up on that.
Do you know if it led to any government responses?
Sadly, in the time frame I was there, it did not. They were, this was newer work and maybe considered an annoyance from the road commission. But I will see if anything ever came out of that as well and forward that on to David.
Good, thank you, Mark. Let's see. Rob is asking, if Enviro.
Changing the subject here, so.
Yeah, that's fine, that's fine. LTE SIM, you can receive text messages. I think that is a question for Shannon. I would shoot an email to Shannon or post it on the EnviroDIY forum, Rob. I don't think Shannon is on today. I don't think she was able to attend today.
Yeah, I thought she was going to be here, so I was kind of.
Yeah, sorry about that. She and Rachel are just really swamped right now with just, stuff out in the field.
I'll definitely reach out to her. Thank you.
Okay, good. All right, well, we are at 3:30. Anything else from anyone? All good? All right, well, everyone have a good weekend, and please be in touch if you need any support with this chloride stuff or with your stations.
Great holiday.
Yep.
Happy Thanksgiving.
Yeah, holiday too.
And stay safe.
Yeah,
Excellent.
absolutely.
Just remember, Thanksgiving occurs during Indigenous Peoples Month.
Good reminder, Carol. All right, bye all.
Thank you. Bye-bye.
Bye.